let's go to page 11 and let's go to number 4. Okay, number 4 it says plot a pair of points. So let's go and plot that. Okay, so first point is 3, 1. Second point is 7, 4. And it says find the distance between them. Now again, you can see from here, this is going to be, if you were to draw a triangle, this is going to be 3, 4. So right away, this is equal to 5. But if you don't see that, you can use the formula. Okay, so that's going to call this point 1 and this point 2. So the distance, use your distance formula, would be x2 minus x1 squared plus y2 minus y1 squared, right? So you can use your distance formula and just substitute everything. So that's your x1, y1, that's your x2, y2. So just use your distance formula. So you're going to get 7 minus 3 squared plus 4 minus 1 squared. So distance is equal to square root of 4 squared plus 3 squared. So distance equal to square root of 16 plus 9. So distance equal to square root of 25. So distance equal to 5. Okay. Let's go to number 8. Number 8 is the same thing. You got the 2 points. Okay, so this number 4 is 3, 1 and 7, 4. Okay, number 8 is same thing. So you got 0, 4 and negative 3, 0. So again, first thing you need to do is plot the 2 points. So make sure you follow the instruction carefully and make sure you do all parts. So first point is 0, 4. So 0, 4. And next point is negative 3, 0. And then you're looking for the distance between them. So you can see that this is 3, this is 4, so distance is equal to 5, right? That's your spatial triangle 3, 4, 5. Right, and if you don't see that, you can use the formula. So this is point 1, this is point 2, so that's your x1, y1, that's your x2, y2. So use your distance formula. Okay, so you're going to get again x2 minus x1 squared plus y2 minus y1 squared. So substitute everything in here. Okay, so you got 0 minus negative 3 squared. And then you have 4 and a 0. So it'll be 4 minus 0 squared. And after that, it's just a matter of working things out. So you're going to get 3 squared plus 4 squared. So distance equal to square root of 9 plus 16. So distance equal to square root of 25. So distance equal to 5. Okay. And make sure you read the instruction. Make sure you answer all parts. Okay, let's go to the next one. Okay, number 12 is the same thing. You got 3 points. Now you got a 2 points, the negative 3 and negative 3, 2, 2. So you can plot this over here. So first part is plot the 2 points. So you got negative 3 over here. Second point is 2, 2. And then you want to look for the distance. So again, if you draw your triangle, you can see that this is a spatial triangle. This is a 45, 45 triangle. So this is 5, 5. So this would be 5 square root of 2. But again, if you don't see that, you just go and use the formula. So 0.1, 0.2. So that's your x1, y1, and that's your x2, y2. Okay, so use your distance formula. So distance equal to square root of x2 minus x1 square plus y2 minus y1 square. Okay, so you can just substitute all the numbers in here. So you're going to get 2 minus negative 3 square plus 2 minus negative 3 square, and then you work it out. So this will give you 5 square, this will give you 5 square. So distance equal to square root of 25 plus 25. So distance equal to square root of 50. And if you simplify, so this comes out, so it would be 5 square root of 2. Okay, so again, I'm going kind of fast because all these are very basic stuff. Okay, let's go to number 16. Okay, number 16 is a sort of triangle with the given vertices and find the length of the sides. Okay, so you have 3 points. Okay, so I'm going to sketch this. So point A is 0, negative 3. Point B is 3, 0. Point C is 0, negative 4. Okay, so I'm going to shift these things a little bit. So this point A is 0, negative 3, and this is B, 0, negative 4. Okay, double check. So 0, negative 3, 0, negative 4, 3, 0. Okay. Okay. And so again, follow the instruction. You draw the triangle. Okay, so we did that. Draw the triangle, and find the length of the sides. Okay, so let's do the AB. So length of AB, just from here you can see that it's equal to 1, right? Or you can just use or this is C. Okay, so point AC is length AC is equal to 1. You can just minus that and take absolute value, right? This is the vertical distance. Okay, and AB. Okay, if you look over here again, this is 3, this is 3, right? So AB would be 3 square root of 2. That's your 45 spatial triangle. Or you can use the distance formula. So I'm not going to do that again. So you can do that. And BC is going to be 3, 4, 5. Right? And if you look at it, it's 3, 4. So this will equal to 5. Okay? So all these are spatial triangles. Okay, and that's it. Very simple. Okay, let's go to number 20. Okay, so you got the 3 points. Point A is a negative 2, negative 3. B is at 4, 3. And C is at negative 3, 4. Okay, so you want to plot the points. So this is number 20. Okay, so first point is -2, -3. B is 4, 3. And third point is -3, 4, -3, 4. Okay, so it says draw a triangle. I can follow the instruction part by part. Okay, so we did that and show that the triangle is isosceles. So to show that isosceles, you need to follow all three sides. Okay, and again, the way to do that is you just go and use your triangle. Use your Pythagorean theorem, right? So again, this is 1. So this is 7. So use your Pythagorean theorem. So this will square root of 50. Okay, again, you don't have to simplify yet. Again, if you do that, again, this is 1. So this is 7. So again, a squared plus b squared, and take the square, so it'd be square root of 50. Okay. So since we did that, we don't even need to do that because we can see that these are equal already. Okay. So you can see that BC is equal to AC. Therefore, okay, the 3 dots means therefore triangle ABC is isosceles. Okay, and that's it. So that's how you do the proof. Okay, let's go to number 24. Okay, so you got 3 points. So A is 5, -2. B is 1, 1. C is 7, 9. Okay, so you can plot the 3 points. Okay, first point is 5, -2. Second point is 1, 1. Third point is 7, 9. Okay, so you draw your triangle. Okay, so you can follow instruction. So first, draw the triangle with the vertices. Show that this is a right triangle, and they want you to do it by showing the square of the longest side is equal to square of the sum of the remaining side. Okay. Okay, so it looks like this is the longest side. So you have to get all 3 sides, right? So I can use your Pythagorean theorem. Okay, so you do that. So this is 2, right? I can just count the square, or you can just subtract, right? So you can, so 7 minus 5 will give you 2, and this one 9 minus -2 will give you 11, or you can count them. Right, so this is 11. So use your Pythagorean theorem. So this will give you 1 square root of 125. Okay, so 121 plus 4 give you 25. Okay, again, you do the same thing. You just go and draw the right triangle. Right, that's what the distance formula is. It's based on the right triangle. So here it's 1, 2, 3, 4, and this is 1, 2, 3. So 3, 4. This would be a 5. Okay, and then do the same thing over here. So again, you can apply the distance formula, right? So again, 5 minus 1 will give you 4. -2 minus 1 will give you -3, and you take absolute value, right? Okay, so over here, same thing. You can count the square, or you can subtract. Okay, so 7 minus 1 will give you 6, and this one 9 minus 1 will give you 8. Right? Or you can count it 2, 4, 6, and this 2, 4, 6, 8. So this is your spatial triangle 6, 8, 10. Okay. So now to do the proof. Okay, so AC is the longest side, so AC is equal to square root of 125, and then so AC square equal to 125, and the other two sides, okay, AB equal to 5, so AB square equal to 25, and then over here the BC is equal to 10, so BC square equal to 100. Okay, so therefore AC square equal to AB square plus BC square. Okay, and again, that's what you want to show. Right? Okay, let's go to 28. Okay, 28, you want to see if those 3 points are same distance from the negative 2, 4. So again, you got A is negative 5, 6, B is 2, 5, and C is 1, negative 2. And you want to see if they're all equal distance to, I'm going to call that, call it D, I guess. Okay, so negative 2, 2. So you want to see, are all these the same distance? Okay, so again, you can go and plot it out, and you can figure out the distance on each one. Okay. You can just use the distance formula, okay, but you also can sketch it out to give you a better picture. Okay. So A is negative 5, 6. So here's your point A. B is 2, 5. C is 1, negative 2. And I'm going to use this one to get D. So D is negative 2, 2. So that way I know that is a reference point. Okay? So you want to find out all these distance, are they equal? Okay? So again, you can just use your Pythagorean theorem, right? And the way to do it is by drawing triangles, right? So this is 3, this is 4, so this is 5. Okay? So AD is equal to 5. Again, you do these things over here. Again, use your distance formula. So this is 3, this is 4, so this is 5. And this one right over here. So again, this is 3, this is 4, this is 5. So in this case, it's yes. So just from using the Pythagorean theorem, you can use your distance formula to apply that. Okay, so you can see that so from here you can see that AD, so AD equal to 5, and BD equal to 5, and CD equal to 5. Okay, so therefore, so the answer is yes. Okay. So all are same distance from negative 2, 2. Okay. So again, you got to show the proof. You cannot just say yes without showing any work. Okay. So again, analytic geometry, you have to show the proof how you get the answer. Okay, you cannot just write down the answer without showing any proof. So you have to go through all this process. Okay, so let's go to number 32. Okay, so again, you got three points. I'm just going to call it point A is -3, 1. Point B is 1, 3. And point C is 10, 8. Okay, so by using distance formula and to see if they are on a straight line. Okay, so again, let's go ahead and it's helpful if you kind of sketch it out. So first point is -3, 1. That's point A. Point B is 1, 3. And point C is 10, 8. Okay, so going to do that. Now, by drawing this, you can see that the answer is no, but you have to prove it. You have to show why it's not. And the way they want you to do it is they want you to do it by the distance formula, right? So the way you're going to do that, again, the distance. So we're going to do the AB. So this is 2, and this is 4. So this would be square root of 20, okay? And again, if you look for the distance. Now, if they're on a straight line, then this distance plus this distance will equal to the total distance, okay, if it's on a straight line. If they don't add up, then it means it's not a straight line. Okay, so this is 2, 4, 6, 8, 9. And this is 2, 4, 5. Again, if you use your Pythagorean theorem, so that's 25, and this is 81. So it's 106. So this is square root of 106. Okay? Okay, now if you do the whole thing, if you're going from here to here, okay, so 2, 4, 6, 8, 10, 12, so this is 13. So this is 7. Okay, so again, if you use Pythagorean theorem, you're going to get 49 plus 169 and 218. So this would be, so AC will equal to square root of 218. Okay. So again, in this case, okay, so AB plus BC is not equal to, so answer is no. Okay. So AB plus BC is not equal to AC. Okay. Again, if it's a straight line, this plus this will equal to, so AB plus BC will equal to AC if it's on a straight line. But this one, since they don't add up equal to that, so answer is no. Okay, let's go to 36. Okay, it says find the point on the y-axis that's equal distance from -4, 2, and 3, 1. Okay, so let's go ahead and, again, it's very helpful if you go and sketch out your information. It helps you to visualize. Okay, so so you're looking for a point on the y-axis that's equal distance to -4, -2. I'm going to call this point A. Okay, so you can feel free to label your points, give a name like A, B, or C, or whatever. The second point is 3, 1. Okay, and you're looking for a point somewhere on the y-axis. Okay, and so again, we don't know where it is. I'm just going to put a random point right over here. And I'm going to call that C. Okay? So since it's on the y-axis, then x equal to 0, and the y we don't know, so just keep it variable. Again, if you know, then you put down a number. If you don't know, keep it as variable. Okay? Again, so this point is on the y-axis, so you know that means when x equal to 0, but the y you don't know because it can be anywhere, right? Okay, so now you have to apply the condition, okay? So I'm going to call this D1 and call this D2, okay? So now you have to try to fulfill the condition, right? It says equal distance, right? So since they're equal distance, again, you apply the definition. So since they're equal distance means D1 equal to D2, okay? And since this is distance, so you use the distance formula, okay? So distance formula is going to be x2 minus x1, so it'll be 0 minus -4 squared, plus y2 minus y1, so it'll be y minus -2 squared, right? So that's your D1. And D2, you're going to do the same thing. So you're going to be 3 minus 0 squared, right? That's your x2 minus x1, plus y2 minus y1, so it'll be 1 minus y squared. So again, you start with your definition, and you just apply the formula, and you work it out. So since I have square on both sides, I'm just going to square both sides to get rid of the square root, and I'm going to simplify this a little bit, okay? So this will give me 4 squared, and this will give me y plus 2 squared, and this will give me 3 squared, and this will give me 1 minus y squared. Okay, the next thing I'm going to do is go and work everything out. So I got 16 plus y squared plus 4y plus 4. Again, when you square binomial, make sure you remember the middle term. This would be equal to 9 plus 1, right? You square that, and your middle term would be minus, not sure, I have a y squared over here. So be careful how you copy things. So again, if you not be help you to find the mistakes very quick. So it'd be minus 2y plus y squared. Okay, so now you're going to solve. So you can minus, that's going to simplify things a little bit. So you got y squared plus 4y plus 20 equal to y squared minus 2y plus 10. Okay, so you can minus y squared on both sides. So that way this cancel out. And I'm going to move the y to this side, so plus 2y plus 2y. Again, write down what you're going to do and then do it. That will help you avoid careless mistakes. I'm going to move the number to this side, so minus 20, so this cancel out. So I got 6y is equal to negative 10. So divide by 6. So y equal to negative 5 over 3. Okay? So the point that you're looking for, so the c is going to be at 0, negative 5 over 3. So about negative 1.6. So we're pretty close, right? So negative 5 over 3, so it's almost exact. Okay? And so that's it.